we're just gonna look at some parts. Then we'll say even in class they're not gonna look at everything. So it's good to attend and see what parts are they gonna focus on, so that you don't study things which you didn't do in class, right? So first thing that we can look at from this chapter, we can see we are saying that here we're going to be focusing on the x86 processor architecture. So the first one was overview concepts. We're just doing some overview concepts. Then on this one, we'll be focusing on what makes up this processor, right? The things that we'll be using within the process, like registers. You see what they say here: processor architecture, memory management, 64-bit processors, components of this microcomputer, and also the input and output systems. So now, starting with some general concept, we have the basic microcomputer design, the instruction execution cycle. So usually you'll also see, when it comes to the instruction execution cycle, also on how does the file operate within the computer when you want to execute a file, when you want to store information, and so on. But we'll be based more on execution, since we'll be programming, then we execute our programs. So we'll be learning from reading from memory, also where we'll check some registers that will be part of such a procedure, and also how to run a program, or how programs run. So basic micro computer design. This one, first we're gonna check that it uses the clock, synchronizes CPU operations, and also the control unit. Based on the control unit, the CU, this is going to coordinate the sequence of execution steps. So, and also the ALU perform arithmetics. Then for these ones, right, within the chapters, chapter 3, 4, 5, we'll focus on these chapters in this information in detail, on what happens when we're dealing with the ALU performance arithmetic, and also the control unit. And also we look at the bitwise processing. So this is not the kind of information that we're gonna be looking at for now. So this one we're just gonna skip this for now. And then also the clock, we'll skip this for now. And then let me see the clock. They say synchronizes all CPU and bus operations. Machine clock cycle measures time of a single operation. And then clock is used to trigger events. So these ones, yeah, we're gonna be looking at them at a later stage. Now, when we come to the instruction, this one is there, instruction execution cycle. Yeah, this one also we're not gonna be looking at it now. The instruction reading from memory also is not something that we're gonna be looking at, because reading from memory and H memory, usually this one for the H memory, you do them in final level, right? Here you're just having some introduction, which the context is not more based on them. But we're also going to look at them, how a program runs. We're not also going to look at this. But for detailed explanation of this, what I can say, or just a summarization, right? First, when we look at this, they say that first we have a user, which is me and you. Then a user sends a program named to the operating system. And what happens is that searches for program in the current directory or the system path. So here it's like when you remember from Java, when you want to use code, let's not talk about code blocks, that one's from C++. When you want to use Visual Studio, right? You enter Visual Studio, you open a folder, you create a new folder, or you just use an existing folder, then you create your file. Now, when someone comes back to the same Visual Studio after it's closed, when you open it again, it's gonna display you some of the names of these folders there. Or you can just easily open a folder and then you search the folder, then it takes you to the system path, right? Again, we can check this here. They say that it gets clusters from directory entry and also loads and start a program, which also can return back to the operating system, right? So this is just also on how to run programs. So this will learn how to run programs when we are busy coding. So now it means that we need to focus on the coding part, like registers, things that we're going to be working with before we can come and focus on how to run a program. Because you can't run a program if you don't know how to send a program. We say right now. So that's the first thing that we're going to be focusing on. So on the IA32 processor architecture, we're going to be looking at the mode of operation, basic execution environment, the floating point unit, and also the inter microprocessor history. So if I check these, so when it comes to the modes of operation, we have the protected mode, which are the native modes, right? And then which is the Windows, Linux, and also for the real address mode, we have the native MS DOS. So the reason why I'm saying that we're not going to be looking at this now is because you can see that this is just theory based. So it's something that everyone can read, right? So I'm not just going to be here reading these things for you. I know that you can read. So what I'll be focusing on, I want to focus on the parts where I know they need explanations, right? Like this one. That's the first part which we're going to be starting with. So we're going to be starting with the general purpose registers. So when we come to the general purpose registers, we have these registers which are called the 32-bit general purpose registers. We have 32, 16, 8, right? So when you come to these are, you see that they say that the named storage locations inside the CPU optimized for speed. So every register has its own work, even though some are just going to be assisting other registers or just going to be acting as a reserve registers, right? So the first one that we have the EAX. So we have the EAX. Second one, we have the ABX, ECX, EDX. So if you check, these registers are a bit easier to memorize, these four, right? Because you only change the letters here, A, B, C, D. So this, the main idea is not just to memorize, is to be able to know what this register is for and also what is it used for, right? Now, if we check the other ones which we have the EBP, which the P stands for a pointer. We have the ESP. We have the ESI, which the I stands for an index. So we'll learn when do we use the index register, when do we use the pointers, right, registers. So we have also EDI. So now we can first look at EAX. So when we usually EAX, let me say this. I don't know if I can. I don't want to move out and create a page, right? Let me see. Yeah, but I can write here. Yeah, when we come to the EAX, mostly this one is called an accumulator. You see right now, this is called an accumulator. This is called an accumulator. So what an accumulator is used for, it's gonna be used for the arithmetic operations. Remember when we're looking at some parts here, let me go back and show you. When we're looking at some parts, I said that these are the things which you're gonna be focusing on at some later stage. But now we still need to understand the registers, where we spoke about the ALU and also the unit control, right? And then let's see it somewhere here, where we had the control unit and also the ALU performs arithmetic. You see, right? So you learn about these on when you're coming to run some programs. That for us to use EAX, we're gonna use it when we're running arithmetic operations. So this one is used to run arithmetic operations. And then the EBX is usually called the base index. This one is called a base index. This is called a base index. You see, these letters, they all stand for something. You see right now, they all stand for something. So the ECX, this one is for, it's gonna be for the counter. You'll see when you are focusing on loops, when we are converting loops from C++ to assembly language, we're gonna be using mostly the ECX, which is for counter. Now the EBX, which is a base index, this one is gonna be used for indexing and also addressing. So we'll also see what is to index and also what is addressing, right, in this portion or this part of the process. So we come to EDX. The EDX will stand for, this one is data. This one usually is for data. It is used for input and also output operations. This is used for input and output operations. So let me just write here, input.
Yes.
Oh yeah, I'll be back now. Let me yeah, so the EDX, which is for data, it is used for the input or output operations. So I'll just write input or output. This is for the input or output. Then the ECX, it is used for loop counter. So remember I said that when we are going to be using converting those loops from C++ to assembly language, or when I want to write a program that loops, so I'll be using the ECX. Now the base index, this one we said that this one is used for indexing and addressing, and also addressing. And then the accumulator said that this is used for arithmetic operations. This is used for arithmetic operations. So we're gonna be working with this when we come to these programs that we're gonna be creating, right? Now, if we check the ESP, these ones usually are gonna be there. Most of them are gonna be there just to assist, right? Like remember I said that the base index, EBX. Now when we look at the ESI, those are also the index registers, right? The ESI and also the EDI. Now, to focus on this, now when we check the EBP, remember the pointer said that this one is for a pointer. And if I check this inside here, they usually stand for something. You see right there. So the EBP, this one is for the base pointer. This one is for the base pointer. This is for the base pointer. Remember the EBX is for the base index. Then the EBP is for the base pointer. Now, what the base pointer does, this one will be used to point to the base of the stack frame. So we'll also focus on what is the stack frame. Also, this one will help to actually access certain things. Or let's say I have, let me say this. Let's say this is pointing to B. You see right now. So if I want to access some local variables and arguments within this, I'm gonna be using the EBP. You see right, which will be the base point. It will be the one pointing to the other part. So this will be used to help with accessing those local variables and also the functions, also some arguments, which we'll learn what is an argument. We'll also check what are the functions that we're going to be focusing on. Then the ESP, this is for the stack pointer. This is the stack pointer. This is the stack pointer. Now this is the stack pointer. Now when we the ESI, I will explain the stack pointer. Let me the ESI, this one will be the source index. Then EDI is a destination index. So remember those ones of source and the destination. You were busy doing this in SCOA021. So the EDI is for the destination index. This is the destination index. So there, let's first look at the stack pointer. The stack pointer. Yeah, I think we can first look at the stack pointer, and then we explain the source index, and also we explain the destination index. So when you focus on the stack pointer is not going to be that different from the EBP. Remember, this one, it points, this EBP points at the base of the stack frame, right? It points at the base of the stack frame. But this one, the stack pointer is not going to point at the base. This one is going to point at the top. You see right now, this one is going to point at the top of the stack. We see right, this one points at the base, this one at the top. So if I have something like this, let's say I have a certain frame, the EBP will be pointing, not EBP, ESP will be pointing here, then the EBP will be pointing here. If this will be moving in that direction, right? But usually here, we don't move in that direction. We usually move in this direction. Remember, if you are stacking something, these things will be coming one by one. You put a book there, you put another book, you put another book. So they are stacked in this pace, right? So to be moving downwards. So we'll also learn on how to stack and also that. So we know now that the stack pointer points at the top of the frame, then the base pointer points at the base of the stack frame, right? And then now when we come to the source index, and another thing you need to know before I forget about the stack point is that this one will be used to push and pop data. You see, right? If I stack something, if I stack books, and I want to, when I'm stacking books, I'm pushing. You see, right? When I want to take out a book, I'll pop. So this is what the ESP will be used for popping and pushing data. Now, so in other words, it will be used to manage the stack. So what we use to manage the stack is the ESP, this register. Now, when we come to the source index and also the destination index, the source index is gonna be used as it's just gonna be a source. This one ESI is just gonna be a source index for string operations. We say right now, and then EDI is just gonna be a destination index for string destination for your string operations. So what the EDI does, this one usually, actually not what it does, right? Usually this is gonna be used as a general purpose register or some sort of a reserved register, right? But we'll see there on how do we use it, when do we use it. And also we talk about, let's say I'm storing data now. When I'm storing data here, there are going to be some register addresses here. You see right now, we'll decide to which register is supposed to manage those addresses and which register is supposed to pop and pop out, which that one we know that we have learned that it's going to be the ESP, which is going to be the stack point, which pops and pops and push, yeah. And then also which manages the stack. So if we focus on a stack, we know which register will be pointing there. And at the base, the register that will be pointing is the EBP. Then these are just going to be used for operations, right? These are just going to be used for operations. Usually those operations that were used too. So Now, when we come to the 16-bit segment, we also have what we call the 16-bit segment. So let me just erase this. Then we focus on the 16-bit segment. Now, we have what we call the 16-bit segment, which also these ones, they explain themselves. Here you're gonna know that for when we come to the 16-bit segments, S will stand for a segment. You see right now, this the second S, not all the S, the second one, the last one. You see right now, it will stand for a segment. And C, so the first one is called this pen. This first one is called a code segment, right? The first one is called as the code segment, and then this one is called data segment, and also I think which one? This one, yeah, this one is an extra segment. So this is a code segment, extra, and this one will be data segment. We say right, so it is much easier for you to know these three. You see right, and we know this one, that S here will be for a stack segment. Then these two, the F and S, this is just called F segment. This is just called G segment. You see right. So now with these, the segments, these ones we're just gonna use them for the main purposes of, let's say, an index or a table indicator and so on. So these are just gonna be the memories segments, and also they're gonna be used to protect memory. So in most cases we don't focus on this, but if we come across any part where we have to focus on them, I'm gonna be explaining why are they using the code segment, why are they using the extra segment, why are they using a stack segment. Already we know that when we come somewhere here on this one, this two, you know that this one is a stack pointer, this one is the base point. So we know that when we come to this two, obviously the stack pointer can be used somewhere there. You see right, also the stack segment can be used in those registers. So we'll learn on which one do we use. Do we use it here, or do we use it on the other register, and why and when can we use it? You see right now. So now the next thing that we're gonna be looking at is, if we go back to our 32 registers, 32-bit registers, we have what we call EAX, right? This 32-bit register. This EAX can be broken down into two. We can have AX and something else, right? Usually this one is just like this. Then when we have this AX, the AX, this one is 16-bit, but it's not a segment register, right? It's just a 16-bit register. This is 32-bit. And then the AX will will produce A lower and A high. These are the 8-bit register. So now let's say this. Let's say this AX, right? Let's say it's like this. Let's say we have AX. If we divide this into two, we're going to get AX. And if we divide this into two, we're going to get AL and A high. So when you are applying those, remember this is going to be used for arithmetic operations, right? So when you are busy with those arithmetic operations, maybe adding, moving, subtracting, multiplying, the data need to be stored somewhere, and a certain register must be used. You see, right? So now we'll no longer use those registers of R1, R2. We'll be using the exact register. You see right now. So let's say I use AL. I know that my data is it's either it's less than 8-bit or it's 8-bit. So the reason why we need to know which exact register to use is so that we don't waste space. Let's say I'm using my problem consists of 8-bit storage, but then myself I come and use 16 or 32. I'll be wasting a lot of storage because on that 32-bit only 8 will be used, or only the minimum of that arithmetic will be used. You see right now? Then I'll be wasting the rest of the storage. So we're gonna be leaning on which register can I use. If I'm applying this, which register can I use? It means that we're gonna be checking those if I'm adding hexadecimals, or we know that these hexadecimals are 16-bit. If I'm adding, also it will depend on how many letters were given there. So if I'm adding decimals, and if there how many, we're gonna check how many bits this data will consist of, or the binary. If I'm adding them or subtracting or moving or doing anything, I'll check what how many bits does this contain, so I know which register to use. You see right now? So if you move something, let's say you move data that consists of a 16-bit into a 8-bit register, it means that it's only gonna move this data. The rest will be cut off. You see right now? This one here will be cut off. It means that it's only gonna take this the first 8-bit and it forsake the last 8-bit, which will give us a problem. So it means that you need to know a compatible register for such operation, and also the data you're dealing with. So from here, we'll look also at the flags, right? We'll look at the flags, not necessarily this is what I was talking about, when we come to accessing parts of registers. Now we use 8-bit name, 16-bit name, or 32-bit name, which if we here say applies to EAX, ABX, ECX, and EDX. So it will only apply to these registers. Were they? This one. You see right now, the EAX, ABX, ECX, EDX, not the stack pointer and also the base pointer, the stack index, data index, right? So when we look at the EAX, as I said here, if the EAX is divided into 2, it will give us AX, which is 16-bit, and if the 16-bit is divided into 2, it will give us A high and A low, which is 8-bit plus 8-bit. You see, right? So which means that we can also have all of them. This one, BX, ABX, if it's divided, it's gonna give us BX. If BX is divided, it's gonna give us B high, B low. Even ECX is gonna do the same thing. C high, C low, D high, D low. You see right now? So we learn on which one will store which information. So yeah. Now, if we come to the index and the base registers. So with this one, some registers, they say that some registers have only 16-bit name for their lower half. So for their lower half, they only have a 16-bit name. So it means that these ones, they never go to 8-bit registers. You see, right? They are the ones here. The ones here on the right. They never go to 8. They only end at 16. So when we consider the 16, we only get rid of the E. You see right now? If the moment you get rid of the E, those ones are the 16-bit. Even here, you see the same thing. The moment I get rid of the E, I get the 16-bit. The only difference between these and the other ones, that these ones, they do have the high and low. They do have the 8-bit registers, and those ones, they don't. So now we can come to some specialized register uses, which we also discussed this, that the EAX is the accumulator, which does the arithmetic operations. The ECX is the loop counter. The ESSP is the stack pointer. ESI and the EDI, these are the index registers. You see, right? And then the ABP, these are the extended frame pointer stack, which I said that this is a base pointer. So reason being because it will point at the base of the stack frame, right? And then we have the segment registers, which these I just said that these ones are defining themselves. Remember I said that this one is the code segment, this one is the data segment, stack segment. I said that this one is an extra segment. Then these ones are just F segment, G segment. These are just additional segments, these three. So that's why there when I was labeling them, I had to start with these ones. Usually I think I started with 1, 2, 3. So that is an extra segment. We have a stack segment. So some specialized register uses the EIP. This is the instruction pointer, and also the E flags. Remember I said that on the E flags we'll be looking at the status flags. So right now we'll be looking at the status flags, but the E flags contain the status and the control flags, and each flag is a simple binary bit. So we'll be looking at such 1 or 0, and where does it apply? You say, right? So those are the status and control flags. So we'll be focusing that on the status flag. So when we come to the status flag, we have a carry. Already we know what is a carry, right? But in this case, we'll be defining a carry in detail. Usually we used to just carry a number if it is out of range. Usually most would not know that it is out of range, but you should know that when I take 1 plus 1, let's say this is like this, right? I can't just come here and write 10. Where am I going to put the number for this one? You see, right? It is said to be out of range. So I'm just going to put 0. Then I carry 1 there. So I add that 1 plus 1. I get 10. Now I write it there. You see, right? So when we talk about a carry, so a carry is just an unsigned arithmetic out of range. So just a positive number. When we say unsigned, we are focusing on a positive number, which is out of range. Then when we now have a negative one or a signed arithmetic value which is out of range, we call that an overflow. You say right now, if it is positive, we call it a carry. If it is negative, we call it an overflow. So a sign here is a result. A result is negative. You see, when we're talking about sign, this is negative. When we say a sign is result is negative, and 0 result is 0. Now we have what we call an auxiliary carry, which this is a carry between 3-bit to 4-bit, or from the 3-bit to 4-bit, which also, this one usually we don't discuss about it in most cases, but if we come across it, we're gonna be looking at it. So the ones that we focus on are the carry, overflow, sign is 0, and also the parity, which is a sum of 1 bit is an even number. So if we take sum of 1 bit is an even number, we're gonna call that parity. Or they can even tell you, they just give you an instruction, then we'll check on how to execute such. So what we have here, let me check this. These are the floating point MMX and XMM registers. Yeah, for the time being, we're gonna skip this. We're not gonna be discussing this. The ones which I want us to discuss, let me just check the ones which I want us to discuss. Yeah, we're also not going to discuss the 64-bit general purpose registers for the time being. But what I can tell you, right, the 32-bit, to show that it's 32-bit, it's represented by E. You see, it doesn't change anything as long as you know the initial 32-bit registers. What you come to do, you're just going to replace, if you want to represent it in 64, you're just going to replace that E with R. You see right now, everything is the same, you just replace with R. So we're not going to discuss this in most cases. So yeah, and also these, they don't discuss them. But the difference is that for the 32, you just put D. For the 64, you don't put. So that's why you didn't see them when we were looking at the registers there. So if by any chance they discuss them, it means that it will be in class, right? If it decides to discuss them. Also, we're not going to look at the motherboard. I think that would be all, if I'm not mistaken, from these. Let me check. Yeah, the last one is this one, the levels of input output. So when it comes to the levels of input output, here for the level 1, we're gonna be looking at the BIOS, which here we check the drivers that communicate directly with devices, right? So these ones where also the OS security may prevent application level code from working at this level. And then the level 2, which is the operating system. This is the application programming interface, where extended capabilities, a lot of details to master. So this one, the operating system, is the one which will be working over time, which will be taking your instructions, running most of the programs and so on. So this is just the heart of your computer system. So when you come to the level 3, we have the high level language function, which will be the C++, Java, and the C++, the Java, and Kotlin, and so on. So these ones, they are portable, convenient, and not always the fastest. You see, right? So the ones which are the fastest will be on the BIOS, because these ones, they can directly communicate. They can communicate directly with the devices. Where we're going to be talking about the assembly language, which is closer to the computer system, also closer to the machine language, which when we've seen that in chapter 1, which it will be the one that in most cases it will be faster when it comes to programs that require fast running. So yeah, that will be the last thing to check there in this case. And also we have the displaying a string of characters. So they can also tell you sometimes they can tell you to draw a diagram that displays a string of characters and discuss it, right? So obviously the level 0 will be a hardware, because all these things are attached to the hardware. So whether it's a software or a hardware component. So when they say that when a HLL program displays a string of characters, the following steps take place. So the HLL program, this one is a high level language, right? So the first step is that we need a hardware, a BIOS function, OS function. Obviously a hardware cannot run without an OS, right? Then also an application program. So when you open an application program, this is where we're going to be talking about some cache memory. Just that you guys don't focus on these things the most. But if you're going to be doing an operating system, finally you'll see that when you open a application program, the application program will send, and it's like you're sending an instruction to the OS. So it's going to temporarily run that storage in the virtual memory so that it can be fast, right? Then that's why we have what we call an H memory. Even in your applications, you can even open any application or WhatsApp. You go to settings, those settings for storage. Then you check that you can clear H memory. After when you clear it and you enter WhatsApp, it's going to have to load again to send an instruction to say that I'm now accessing WhatsApp. So it can load everything that I have and allow me to use the virtual memory or the H memory so that it can store those things. That every time I enter the WhatsApp, I can get fast updates. I can also be updated while I'm outside, right? So those are the kind of things which will be taking place. So you see that I said that this assembly language, so these are the programming levels that we're going to be taking to accomplish these assembly language programs. So they say that the assembly language programs can perform input output at each of the following levels, even though it require us to modify the level of language that we're using when we are moving to each function. So we'll also look at the library. In chapter 3, you'll focus on the library, on the libraries, and so on. So now that will be all for this session. So we focused on the things that matter the most. So now I can give you an exercise to say, go search what this means. You can go do some research on what does this say, right? And then I think we'll be done for now.